This video is an overview of the confidence interval. The confidence interval for the population mean mu when the standard deviation of the population sigma is known, and we can find the confidence interval for the population mean mu when sigma, the standard deviation of the whole population, is unknown to us. We can also find the confidence interval for the population proportion P. So the objectives of this video is to see what a statistical estimation is, to learn about the margin of error and confidence interval, and in particular, we are going to see the confidence interval for the population mean mu when sigma is known, and we are going to explain that as an interval x bar plus or minus z star sigma by square root of n, or using our TI, we can apply the 7z interval. And also, we are going to see the confidence interval for the population mean mu when the standard deviation sigma is unknown to us. And we may use the formula x bar plus or minus t star Sx divided by square root of n, or using the TI calculator, we'll use number 8, which is the t interval. And finally, we'll see what the confidence interval for the population proportion is, using the formula p hat plus or minus square root of p hat 1 minus p hat divided by n, or using the calculator, it is 1 proportion z interval. Here sigma is the standard deviation of the whole population, Sx is the standard deviation of the sample, p hat is the proportion of the sample. So these are all the statistics. Now, statistical estimation. If you have picked different samples from a population, you would probably get different sample means x bar, and none of those will be equivalent to the true population mean. That is, if I have a huge population and if I pick small samples from this, say of size 217 from this huge population, then the standard deviations, or the mean of these simple random samples, will differ. See, one is 132.5, the other one is 134.2, the other one is 131.8. So none of them will be equivalent to the true population mean mu. So we can have a representation for all these means of the simple random sample. That is, we can find the mean of this sampling distribution x bar, and the mean of the sampling distribution x bar will come closer and closer to mu, or the sampling distribution will follow a normal distribution with the same mean mu, standard deviation sigma by square root of n. We learned that that is what is the central limit theorem is. And according to the law of large numbers, when we repeat this process a number of times, when n is large, the mean of the sampling distribution comes closer and closer to the mean of the whole population. So when we are trying to estimate, if it is not a point estimation, if it is an interval estimation, then for the true value, there can be an error on either side, plus or minus m. So the interval will be x bar minus m will be the lower limit, and x bar plus m will be the upper limit. Or we can write that as x bar plus or minus m, where m is called the margin of error. So the confidence interval C represents the area corresponding to the size C. If it is 95% confidence interval, we are trying to find the probability corresponding to that 95% interval. So the confidence level C determines the value of Z star, where Z star is the Z value, the critical value, using the table C. The margin of error depends on z star because the margin of error is z star times sigma divided by square root of n, where z star is a critical value, sigma is the standard deviation of the whole population, n is the sample size. The z value can be obtained using the table C or table B. In table C, you can find for the corresponding confidence interval, you can find the value for z star. The same table can be used for the next confidence interval t values also. So the confidence interval for the population mean when the standard deviation sigma is given is x bar plus or minus z star sigma by square root of n. The z star sigma by square root of n is the margin of error. And the z star can be obtained using the table. In particular, for a 90% confidence interval, the critical value z star will be 1.645. For a 95% confidence interval, we can find that it is 1.96 using the table. For a 99%, we can find that the z star value using the table C as 2.576. Next, when you are trying to find the inference for the mean of the population when the standard deviation sigma is unknown to us, we can make use of the standard deviation of the sample, which is S with the suffix x. In this case, we cannot use the z interval, but we can use the t interval, where in this case the margin of error will be t star sx divided by square root of n, and the standard error will be sx divided by square root of n. So we will be using the formula x bar plus or minus t star sx by square root of n, or using the graphing calculator it will be 8 t interval. The value for t star can be obtained using the table for a degree of freedom n minus 1, or we can make use of the graphing calculator application. And the third one, if we are trying to find the inference for a population proportion P, then the sample proportion P hat can be used. So if we can use the large sample confidence interval for a proportion, in that case we'll have more accurate confidence interval. And we also need the sample size n, in which case the confidence interval will be p hat plus or minus the margin of error. In this case, the margin of error will be z star times the standard error. The standard error is square root of p hat 1 minus p hat divided by n. So where n is the simple random sample size, and your z star will be the z value using the same table what you got for the z interval. If we are using the calculator, then we may use A, which is 1 proportion Z interval. The plus 4 method will give a more accurate result than the large sample method. So if we are using the plus 4 rule, then it means we are adding 2 to success and 2 to failure. So in general, we are adding 4 to the whole observation. So in this case, the proportion P, the number of favorable outcomes divided by the total number, will not be just x by n, it will be x plus 2 divided by n plus 4. So we treat this as P tilde. In this case, the confidence interval will be P tilde plus or minus the margin of error. In this case, the margin of error will be z star square root of P tilde 1 minus P tilde by n plus 4. The same thing can be obtained using the graphing calculator, but we have to be careful entering the value for x as x plus 2 and n as n plus 4. Sometimes if the p-value is unknown to us, then we need to guess a p-value, and the guess p-value will be given in the question, and it is treated as p star. The options are, we are using p hat if it is a large sample method, but this method performs poorly unless n is extremely large. But If we use a plus 4 method, that is adding 2 to success and 4 to the total number, that is when we use p tilde, even if the sample is small, say in the small as 10, we get more accurate result. So in general, when we are trying to find the confidence interval for the population mean, we use number 7 z interval or the formula x bar plus or minus z star sigma by square root of n. For the population mean, when sigma is unknown, we use 8 t interval, which is x bar plus or minus t star sx by square root of n. When the population proportion confidence interval is needed, then we use 1 proportion z interval or p hat plus or minus square root of p hat 1 minus p hat by n or p tilde accordingly. Now in these two problems, what is shown here, the standard deviation sigma is provided in the question and we are asked to find the population confidence interval for the population mean. So we are using number 7 z interval. In the first case, the data values are given, so we can use the data values in the calculator itself and get the confidence interval. In the second case, the x bar value, sigma, and n, the statistical values are given, so we can use that option, that input, and get the value for number 7 z interval. The next set of problems, the standard deviation sigma is not given to us. The first case, it is very clear that the standard deviation sigma is not there. But in the second question, when we read the question, it says the mean time is 7.41 and the standard deviation is 0.78. That 0.78 is not the mean for the standard deviation for the population, but it is a standard deviation for those 10 randomly selected people, which is a sample. So that is your Sx. So since sigma is not given here, since only Sx is provided, we use number 8t interval. So in these two problems, we use number 8t interval. In this first question, we have p hat to be 15.9. So we will be getting x 15.9% of 1729 will be 273.6. We cannot take that as a decimal because x is the number of observations here. So the number of success, that must be a whole number. So treat that as 274. And when you use 1 proportion z interval, we get the result. In the second case, the n and x values are given. So again, we are trying to find the confidence interval for population proportion. So we use 1 proportion z interval, and this is the answer for that. So this video explains clearly about the method for finding the confidence interval for the population mean when the standard deviation sigma is given, when the standard deviation sigma is not given, and also we learned how to find the confidence interval for the population mean when a large sample is there using a plus 4 rule, and also when we are supposed to get a p star value. Hope this video was helpful. Thank you for listening and thank you for watching.